All right. Today we're going over example 5.8 in the fluids book to learn how can we determine the z factor using the DAX equation. So we get practice on how to get the z factor from the kids chart, and now we want to learn how to do it with the DAX equation. I'll take you through a step by step on how to calculate z factor using DAX equation in this Excel sheet. I will also share with you this Excel sheet so you can practice it in your own later on. So here are the steps. So we have two equations. The first equation to calculate the pseudo-reduced pressure, the pseudo-reduced density, which equal 0.27 times pseudo-reduced pressure divided by z times pseudo-reduced temperature. Then we'll use that pseudo-reduced density in calculating z. Now you notice we have two z's. So the first one we assume is z, in the pseudo-reduced density, then we use it here in the z equation. Our correct answer will be the one where the z calculated will match the z estimated. So we have to follow these steps to calculate or to update our estimate. So the example I have today, we assume the pressure to be 5700 psi, and critical pressure of this fluid or composition is 3000. Temperature is 845 ranking, while the critical temperature is 530. So first step is to calculate the pseudo-reduced pressure, which equals the pressure divided by the critical pressure. So it's E3 divided by E6. And the pseudo-reduced temperature was calculated also by dividing T to TPR. So the first step here is to guess the first z, which we'll use in this equation. So we'll start according to the steps. We have to guess the first start is better to be 1. So I'm going to type 1 here. And then second step is to calculate the density, the pseudo-reduced density, using this equation. So I can even make it better. Let's see if I can copy that. And let's see if I can paste it here. Yeah, not bad, I say. So let me delete this and make this pseudo-reduced subscript. So now we can have a good understanding of what we do. So that would equal 0.27 times pseudo-reduced pressure. So I'll get the pseudo-reduced pressure from here. And now I want to make sure this to be constant whenever I drag it down, because I will drag this throughout the whole different iterations. So to do this, I click in F4 in your Excel sheet and your keyboard, click F4. So I'll click there, so this one, then F4 should get activated here. It's not working for some reason. So the other way to do it is you add a $sign before the E, which will lock it in the E column, and you also do another one after it at the 9, so that means it's locked. So now if I drag it down here, if you click there, you see it still read the same thing. Yeah. So I go back to continue the equation. So we says 0.27 times the PPR, I had to lock it, divided by, gonna open parentheses for the lower part, the z factor. So they guessed z from here. So I'll select the 1. I don't have to lock this one because in the next iteration I need it to be updated, times TPR. I select the TPR here and I want to lock it. So I will do the, there we go. I clicked F4 and you see now this time I did it with the F4 and it worked. So either F4 or you add a $sign before the F and another $sign before the 9. Then close the parentheses, click enter. So this is our pseudo-reduced density, which we'll use in this equation. If you see this equation, it consists of 1 plus the long term plus that second term minus that third term plus this fourth term. So to simplify it, I assumed each of those to be t. So I can even update the equation here if I want to copy it. And then add it below. And the other one. Okay, there we go. So I added it here. Now I can come simply and sub this with t1 plus t2 plus t3 plus t4. Okay? Knowing that t1, t2, t3, as I just explained a minute ago. Okay? Right there. Get this one as well. Right there. Okay, so T1 equals that very first part. So we say T1 would equal the pseudo the reduced density, which is this, times, gonna open big parentheses, right? And I'm gonna close it as well. And I will go click inside here. So first thing, it's A1. So A1, it's right here, and you have to make sure you get it locked. So again, click on the F4. All right. Plus, open another parenthesis. It's A2, so be A2, like it as well, divided by TPR. Click TPR and like it as well. And then close that parenthesis. Plus, open a parenthesis. It's A3, like A3, divided by TPR, like it. Then it's cube. So to do the cube, you click Shift 6 to add 2, and then I'll add the 3. Now I will close the parentheses. Plus, again, it's A4 right there, like it, divided by TPR cube. So TPR, like it, 2, 4. Okay. Plus A5, like it, divided by TPR, like it, 2, 5. Yes, 5. Now close the parentheses for that whole thing on the T1. Now I feel that I missed one of the legs, so let's check. It's the density, which is E18, right there, times okay, all of it are lugs. So very much in this equation, everything will be lugged except the pseudo-reduced density. Okay, so now I can click enter. Now give me an error, so I have a problem with the parentheses. So to double check on that, you click in here, and you see it's always colored. So I have this parenthesis, when I move around it, it gives you the beginning and the end. Okay, so we got this fixed. Okay, 1, 2, 4, 5. So yeah, I'm missing a parenthesis for that last one. I'm gonna add it and close. Alright, so this is what I got for T1. We'll do the same thing for T2, so we'll equal the pseudo reduced, not locked, and will be up to 2 times. Okay, now I see times plus. So let me check the equation again to make sure it's accurate, the one we're using. It's here. So it's A6. So my equation is missing A6, right? A6 plus A7. Okay, good. So I'll come here and I will add the A6. See, it shows up here. I don't know why, but let's remove this. There should be an option to remove or delete. I think I can. Alright, there we go. Okay, get the same fonts. There we go. Now moving back to here, we got the pseudo reduced square times A6, like it, plus open parentheses A7, like it, divided by the TPR, like it, plus A8, and like it, divided by the TPR, like it, to 2. And now I'm gonna like the big parentheses that we opened initially and enter. Then T3, which would equal pseudo reduced to 5 times A9, like it, times open the parentheses, open another one, it's A7, divided by, I forgot to like A7, so I'm gonna click A7 again, like it, divided by the TPR, and like it, plus A8, like it, divided by TPR, like it, to 2, close the big parenthesis, the small parenthesis, then the big parenthesis, and now we're done with T3. Now it's time for T4, which is that last one. That one is a little bit tricky, so let's pay attention and see how good job we can do in there. So we'll start with A10 right there, like it, times open parenthesis 1 plus A11, like it, times the density, pseudo density, we don't like this one, up to 2, right, squared, close the parenthesis, times, open another parenthesis, it's the same thing, the density up to 2, divided by TPR, locked, up to 3. Now, exponential, so we type EXP to get the exponential. I think it should, yeah, exponential of negative A11, like A11, times pseudo reduced density square. Close that parenthesis, and I want to make sure that I did not forget any parentheses, so I'll go up here and move my mouse, make sure, okay, this is for the exponential. This is for that part. Yeah, there is not. Yeah, we didn't have big parentheses. So click OK. Okay. Yeah, we missed the multiplication here. The exponential here should multiply by this exponential. Enter. So now we have our guessed z, density, PR, then T1, 2, 3, and 4. Now we need to calculate the z factor using this equation. So that equation, as you see here, it equals 1 plus, so we're using that one, right? Plus T1. I will not like it because I need to repeat this for the following steps. Plus T2 minus T3 plus T4, enter. So the calculated z factor is 1.17. Now it's time to calculate delta z. Delta z is simply the difference between your current z and the previous z. So it will equal this z minus the previous one. Enter. Now you see here, it's time to update or to give a or get a better estimate or a better guess for the z factor. So when we look at that, uh, it says that if your pseudo-reduced pressure is less than or equal to, we use this one, and then if it's 2 to 3, 3 to 6, and so on. So our pseudo-reduced pressure here is 1.9, so we'll go the first step. So let's say the next trial value of z factor will be the previous trial value plus the delta. So here, you can see it would equal this plus the delta, which is that one. Enter. And now I will repeat this. Same thing for those. I take it next step. I updated my t's. Then the new z factor is 1.33. Then I get the z factor, the delta. It's lower. I repeat the same thing here. So it's 1.17 plus this, right? Then repeat the same thing. And very much do the same exact thing. All right, now you see the z factor, the delta or the error is not improving. That's an indication that there is something wrong in my calculation. Right, so we need to look at that and see what's wrong. So let's review. So one is the first guess, then the density is 0.27, right? Okay, one good thing for you to help you to review is not reviewing it in the same column you developed. Let's do it in the third one. This will help us to see if we missed any of the locks, right? Because if you missed any of the locks, it would have been moved from what you're expecting. So here, I see that we have 0.27 times E9, the pseudo reduced, good. E9 is pseudo reduced pressure, good. Divided by Z, which is this one, the D20, okay, times F9 logged, which is a TPR. So, but this one is correct. Comes to T1. Let's see. It is A1 wait a minute. Alright, see, so it says it should be pseudo reduced density, okay, E20 times A1 C3, okay, plus A2 divided by TPR plus A3, good, divided by TPR cube plus A4 divided by TP4 cube plus A5 divided by TPR to 5. This one looks good. Next one. Same thing. Density square, got it, times A7. Okay, now look at this. It says A7. So A7 here is C9. I have it here to be C8, so I messed that one. I used C6 instead of A6 instead of A7. So I'll change this to 9. Now it's A7. Or no, wait. Let me escape the thing. So we're doing T2, right? So T2 right there. Okay, good. So it's A6 plus A7, so it was correct. So C8 A6 plus A7, which is 9, divided by TPR plus A8, which is 10, correct, divided by TPR squared. Good. Third one, it is density to 5 times A9, which is 11. Okay, good. Times A7 divided by TPR plus A8 divided by TPR squared. Good. Third one, density to, so this is T4. Okay, so it's A10. Okay, let me review T3 again to make sure we get that part. So last thing here we had C, okay, right. So we get A8 divided by TPR 8, okay. Then now it's, oh yeah, small difference between this one and that one. Okay, so you get it correct. Now this one is A10, we get A10 times 1 plus A11 log times density square, good, times density square divided by TPR cube times the exponential of negative A11 density square. Okay, good. Calculation is 1 plus T1 plus T2 minus T3 plus T4. Perfect. All right, I want to make sure that in T3 I didn't use a negative sign. So C, yeah, it was positive. So we're good. Then the delta Z was the difference. Good. All right, so we got it correct. So what we have to do is we have to keep to do more iterations. Let me take this back. Now that goes here, and I'll update all those accordingly. Okay. Let me update all these values. Let's see where we're at. Okay. Definitely there is something wrong. So let's check it again. So say if PPR is less than or equal to, next trial of Z factor will be the previous trial value plus the delta. And delta is the difference between this one and our value, right? So it's 1.33 minus this. Okay. Okay, so we're still looking for the mistake. All right, so when we look at that, so let's review it again. This one looks good. All right, now when we move here, I can see, okay, pseudo reduce the A's and the TPR. Let's check T2. Okay, it says pseudo reduced square. I got, oh, I see. See here, I use the Z, the guessed Z, not the pseudo reduce. So I'm gonna move this to this here. So change the D to E, enter, got a different value. See that one, I assume I made the same mistake. Yes, instead of E, I use D. So I'll go here, change this to E, enter. Here, let's see, yes, I use a guess T, so T4. Yes, so instead of the T, there's D. I'll make it E. There's another one as well. I'm gonna make that E. There's a third one. Where does it have any more D18 in here? C, C, E, E, F. Yes, right there. E. Right. Enter. Then the calculated Z, and this is the error. Now it's time to update. So this one is correct, right? Now it's time to update all those with the new values, right? So I'm going to highlight those, update the rest. Okay, now look at that. So the first iteration, the error was negative 0.12. They became 0.011, 0.001. So 0.001 is an acceptable error if you're doing the calculation by hand. But if you have the computer such as here, you can go for uh, 1 times 10 to negative 6. So let's see how that is. So see that look. Now when you look at the guessed z's here, so we start to get into the 0.865, then 0.868, 0.648. It doesn't change much, and compared to the guess, it's reasonable. So it's within the range. So that would be our value. Usually, whenever we use z factor, we use it in 2 decimals or 3 decimals max. So 0.865 or 0.8648, which will be rounded to 0.865, should be fine. And this will be our initial answer if you're solving this by hand. And if you're doing it by computer, I would go with the fifth or the seventh iteration right there. So when you are to code this, you need to set the iteration to keep going with a condition. So if the delta z is less than 0.0001, for example, then the iteration will stop and you'll take this value as your z. Otherwise, you keep doing the iteration until reaching the final results. So I hope that helped you to understand how you use that equation. And I will share with you the template and the data for this Excel sheet. I want you to try it yourself. Make sure you get the correct answer. And if you have any questions, reach out to me.